welcome to the deep dive. For the longest time, there's been this really captivating idea, this dream of a galaxy just packed with planets like ours, potential homes for life everywhere we look.
Oh, absolutely. That picture, it's fueled so much, hasn't it? Decades of searching, focusing on finding rocky planets, Earth-sized ones in that Goldilocks zone.
Right, where water could be liquid, crucial for life as we know it.
Exactly. And the optimism was, well, it was really high, especially around red dwarf stars. They make up, what, 70% of the stars in our galaxy?
A huge number. And they seemed like prime real estate, maybe easier to spot planets around them too.
That was the thinking. But hold on a minute, because there's this brand new study that's kind of shaking things up. It suggests those Earth-sized worlds might be, well, a lot harder to come by than we thought.
Okay, so not just a small adjustment, you called it a seismic shift before we started. That sounds pretty major in the hunt for alien life.
It really is. This study, it's led by Emily Pass over at MIT. They used a ton of data from NASA's TESS mission, plus some powerful ground-based telescopes.
TESS, right? The planet on it.
Yeah, and their findings point towards Earth-sized planets and those habitable zones being scarcer than we were hoping for.
So this team, Pass's team, they dropped this bombshell. How exactly did they arrive at such a different number? I mean, missions like Kepler, they gave us so much initial hope. What did this new study do differently?
Well, it seems to be about the meticulousness of the approach. They looked closely at about 350 stars, mostly those red dwarfs we mentioned.
Okay.
And where earlier estimates kind of floated around 50%, half of these stars potentially having an Earth-like planet in the right spot, this study found something quite different.
Lower?
Yeah, significantly lower, only about 20%. 20% of the stars they surveyed had planets between, say, 0.8 and 1.2 times Earth size in that habitable zone.
Wow, okay. 20% versus 50, that's a big drop.
It is. And Emily Pass herself basically said, our findings suggest we may have been too optimistic about how common these planets are.
That's quite a reality check.
Yeah.
So how did they nail down that rarity? What was the technique?
They did something pretty smart. They combined the strengths of TESS, which is great at finding potential planets by looking for those tiny dips in starlight as a planet transits.
Like a mini eclipse.
Exactly. But TESS is in space. They paired its data with really high precision observations from the ground, specifically the Magellan telescope.
Oh, okay. So combining space and ground views.
Right. That combination allowed them to really confirm things, get better measurements. They found plenty of smaller planets, sub-Earth, some bigger ones like mini Neptunes, but planets right in that Earth-sized sweet spot in the right orbit. Surprisingly uncommon in their sample.
That sounds incredibly precise, but also really challenging work.
Definitely. And it brings up other issues too, beyond just spotting them. You mentioned the environments around these red dwarfs.
Yeah, are they actually good places for life, even if a planet is the right size and distance? What are the cosmic hurdles there?
Well, first, just detection is tough. Red dwarfs are dim, right? And they throw off these massive flares pretty often. Imagine trying to see a tiny dip in light when the star itself is constantly flaring up.
Right, that would obscure the signal.
It really can. And second, those flares, they're intense. We're talking huge bursts of radiation that could potentially just strip the atmosphere right off a planet, even one in the habitable zone.
So, not exactly a cozy neighborhood.
Potentially not for life as we know it, which raises that deeper question, doesn't it? Are we maybe too focused on finding Earth 2.0? Could life exist in ways or places we haven't even imagined?
That's a fascinating point. Okay, so stepping back, if these Earth-sized planets are rarer, especially around the most common stars, what does this study really mean for, our whole perspective, our place in the cosmos?
It's profound, really. If planets like ours aren't a dime a dozen, then Earth might be, well, more unique, maybe even a kind of oasis.
A cosmic fluke? Is that what we're looking at?
It forces us to consider that possibility. Is Earth this incredibly rare, maybe 1 in a billion miracle, or are we just not looking in the right way yet? Maybe life is out there, but it's thriving on different kinds of planets or under different conditions.
So this deep dive, it really challenges those long-held hopes. It doesn't necessarily say no life, but it suggests finding another Earth might be much harder than we thought.
Exactly. It pushes us to refine our search, maybe broaden our definition of habitable. It's a reminder, really, of how much we still don't know.
It definitely makes you think. Are we searching for a needle in a haystack that's smaller than we thought, or are we maybe just looking in the wrong haystack altogether? Something to keep pondering as the search continues.